defined, floating in the circuit, neon whispers.
Thank you all for staying with us here after a very long day. My name is Alexandru Stan from IN2 Digital Innovations, and as Fabio already mentioned, actually in Sun, we are very much interested in the integration of the different components into a cohesive platform and their exploitation afterwards. With this in mind, I will give now a bit of an introduction on.
So you're talking manually, use the arrows.
Yeah. Here, better. I will try to give you a brief overview of what the Sun integrated platform is, highlighting a couple of the points related to the integration actually. And then afterwards in this session you will be introduced actually to two of the different pilots that we have done in this project. So you will get to see also some live demonstrations. What we have done with the Sun integrated platform is basically to put all the foreground that we have created into the project, put it together under one umbrella. And then we have had already a first round of testing in pilots, in all of the 3 pilots, and now we will very soon, as you heard, start with the second round of testing for also people doing this rehabilitation, so physiotherapy scenario, safety at work scenarios, and also the scenarios for the people with disabilities. Now, when we're speaking about the integrating all of these components into a platform, of course, there are many challenges, and we know that there are many limitations and problems that are faced. So not only you have issues related to the performance and latency that you want to minimize when you have such a platform, in terms of the communication between the components, but of course there are different technologies, different standards that come into play, and for this, of course, you need to have something which is quite decentralized, but still offers a flexible component registration. An important aspect that we had in the project is to tackle issues related to security and trustworthiness. And I'll come back a bit later to this point as well. Also because the pilots have different requirements in terms of how they can be deployed. So for instance, in hospital scenarios, you need a pilot that runs completely offline. We of course had to allow that the platform can be instantiated in both online and offline ways. Then of course you have different experiments running at the same time, and you need of course to understand and to observe what is happening under the hood in order to understand exactly performance issues and possible problems that can always show up in this kind of research scenarios. So for this we came up with this multi-layer architecture, which is modular. It's a bit inspired by the kind of microservices approaches, and we really look to leverage the interoperability between these different components. So you'll see that there are all these different layers here in this figure. Some of them are horizontal, but you will see there are a couple of vertical ones as well, like a cyber threat detection, and very important also this aspect of the tokenized platform, which provides the kind of central storage and persistence for the data that is being exchanged in the applications. There are also some components which sit a bit outside the content creation tools, because those are more standalone components that can help with the creation or refinement of 3D assets. And then in the middle you have the kind of core, which is about coming from the sensors and the data to their processing, and then to the application layer. And all of this is brought together by something which we call the middleware OmniBridge. It acts as a central backbone for communication for all of the different modules. Its focus was really on interoperability, but also we're keeping security, and some support for, of course, for different types of data exchanges, and support for debugging, because that's also very important. So observability was an important aspect too. So in order to build this, we had three different components that made it up. One is a core API through gRPC. So this is done in order to specify how components get registered, authenticated, does session management, and offers a dynamic catalog of services and components which are available. Then for messaging, we used MQTT and an MQTT message broker. So they really takes care of this high performance, high throughput message exchanges. And then there is a monitoring service that provides this distributed tracing and observability. So we try to put together and combine this two of the best worlds in a way. On the one hand, this lightweight exchange of messages, but with, let's say, well-controlled interfaces for specifying what the components can do and how can they interact with one another. I had here a bit of slides with a bit more technical details on each one of this. I will just, let's say, highlight some of the aspects. In terms of the communication protocol, so we chose gRPC and the implementation with protocol buffers over more traditional REST and JSON APIs, because this really provided us with more, on the one hand, performance, because there's a binary serialization there taking place, but also because there are less error prone, since everything is strongly typed. There is a strong contract there. You can generate the code for the clients automatically in different languages, so you could have Java, Python, and other things. And of course, it helps with this bidirectional streaming as well. MQTT is quite common, I would say, in several scenarios. So this really helped us in terms of the high throughput and high performance. I would just say that we used the hierarchical topic organization, but also provided the opportunity to have very custom topic configurations. We implemented the full MQTT level authentication there as well in order to maintain security. So there were a couple of, let's say, optimizations that we of course did under the hood. And for tracing and observability, we took, let's say, a bit of lessons from more microservices and this kind of approaches where we have basically used Jaeger as a framework in order to create this traces which are also persistent, can be exported later on for inspection, and can really help with, let's say, the early prototyping phases for testing purposes. Some words also on the tokenized platform, because this is one of the vertical components that have been used in all of the different pilots. So it had two main roles. On the one hand, it dealt with asset tokenization. We really wanted with Sun to have a secure and trustworthy platform. So based on blockchain technology, smart contracts, and we exploited also fungible and non-fungible tokens. We managed to have a platform that does digital asset transactions, has unique identifiers for each of the pieces of content that are then used in the application. So you could really have a secure marketplace actually in the end for all of these things. And we use the tokenized platform also for this kind of off-chain persistence. So kind of a data repository for data storage, logging, retrieval, and basically connected it also with the more general data spaces concept and implementation. So that's one of the components that will be part of each of the pilots actually. The integrated platform has over 20 components. So as I mentioned, some of them are present everywhere. The cyber threat detection, which I didn't include here in this presentation, the tokenized platform, the avatar pipeline, but then there are specific ones which we use in one pilot but maybe not in the other. For instance, in pilot 2, there is the open vocabulary, object detection, task optimization, hand gesture recognition, and the hololight stream as the components. And in pilot 3, which we'll see later, the list is even longer in terms of components. If you're interested in any one of these components and want to learn more for each one of these, we have set up this kind of online portal where it's easy to search, where you can access each one of these components with information on who is the owner, what does the component do, link to repository, and some of the key features. So it's very easy to find those components that might be more interest to you and to your particular scenarios that you might have in mind. That's the QR code, yes, to reach that. And then now, yes, we're reaching the end of our project soon. So we are very happy that we managed to build this as an open ecosystem, and it's ready now for these cross-domain pilots that are starting very soon, and hopefully after the end of the project, more pilots to come. It's really, we want to, with the Sun integrated platform, to have something that really helps system integrators and XR application developers to lower the costs for building custom applications, for building new functionalities, in order to, let's say, bring this XR world a bit closer to everyday life. So with this, I think we are now ready to see some pilot demos. Thank you very much. I haven't mentioned, but you can also ask questions at any point. So.